This is a lecture 4 in the series of learning about induction motors, and we will learn about rotating magnetic field or RMF in this lecture. It is seen that when the stator winding of a motor is supplied from three-phase supply, that is the AC supply, the three-phase of the AC current will always have a phase difference of 120 degrees with each other. The field or the flux produced in this case due to all the three phases will vary both in time and space and will rotate in space at synchronous speed. The field is called rotating magnetic field. So it is seen that when the stator windings consisting of three phase are supplied with the AC current of three phase, each having a phase difference of 120 degree, the field produced or the resultant MMF and the field produced will be such that it will vary itself in both space and time. So it will rotate. If you look at the phases, then the current supplied in the IA, IB and IC, which are the three phases, have a 120 degree difference. That is the phase or the angle difference, that each of this will be lagging other by 120 degree, so that the first will come and then the second will come and the third will come, and the values will have a lagging of 120 degree, and the resultant MMF which is will be produced due to each of these currents in the winding, that is the A winding, B winding and the C winding. Each of these MMF will also be in phase difference of 120 degree, and when you will sum up or add these three, the resultant MMF will also have a phase difference which will vary in both space and time. If you look at the three phases which you can see as A, B and C are the windings here, only single windings are considered here for simplicity, and if you will see the resultant MMF, then the axes are given axis of A, B and C, and each of these will have a phase difference of 120 degree with each other. And next is the resultant MMF, which will be calculated by summing up of all the previous MMF which was shown for A, B and C. It is seen that the resultant MMF will have a phase difference in both space, that is theta is space and t is time. So it will vary in both space and time. So it will be a rotating MMF, and the speed of rotation of this MMF or field is given by synchronous speed is equal to 120 F by P. Synchronous speed was given by 120 F by P. Also, the frequency of the rotor current will be always less than the supply frequency by a margin of slip. Slip is the synchronous speed minus the rotor speed into 100 divided by synchronous speed into 100. So the working or the production of the rotating magnetic field and the rotation of the rotor, if you see, when the rotating magnetic field cuts the rotor, the EMF will be induced in the rotor conductor, because there will be a change of field which will be affecting the rotor or which will be felt by the rotor. So this will induce an EMF according to the Lenz's law in rotor, which will try to nullify the very cause which is producing it. In this case, the rotating magnetic field rotating at synchronous speed is the cause which is producing the EMF. So the rotor will also try to nullify that cause and it will rotate. So if you see the three different phases, that is the red, green and blue, each of them are lagging behind one another and having a phase difference as it is seen. And if you see that the rotating magnetic field shown by the black arrow, for the green it will have a maximum, and then it will have a maximum for the blue, and then it will have a maximum for the red, and in this way it will keep on rotating as the MMF is rotating. So that's all. If you like this video, please do subscribe, like and comment.